Hello all, my name is Ashwant Singh. So today's talk is about signing tool. You have seen Rustboot, right? So in Rustboot, if you have your firmware, how will you sign a firmware? Okay, so this talk is mainly about how do you sign a firmware, how do you find an image? Okay, if you have an image separately available, how do you sign that and those things? So signing tool is open source repository written completely in Rust. It's available in my repository, available in my GitHub page. So I will show you once I give little intro about what do you need prerequisitely before signing. Okay, so signing comes with something called as cryptography. So cryptography is a practice of secure communication. It involves transforming message or data into unintelligible form called as cipher, so that only authorized individuals can decipher and understand the original message. Okay, so there's something called as ciphertext, something called as deciphertext, deciphering that. Cryptography is of three types. Basically, it's of two types: symmetric and asymmetric. I just kept this hash function along with it because it comes along with the symmetric and asymmetric. You know, it plays a very important factor when it comes to signing. That's why you can also call it as extended type of it. Symmetric is where you have your same key at both signing and verification at the verifications at the verification end. Asymmetric where you have something called as public and private key concept. Okay, let's jump into something called as hashing. So hash function is a function that can be used to map data of arbitrary size to fixed size values. Okay, so you can assume hashing function is like a black box. You send data to it, it's gonna give you the hashed text. Okay, and no hash and there is no way possible that two hash can be same. Okay, so if you have a data of same different types, then hash will also be different. Only if the both data is same, only then hash gonna be same. Okay, so basically a hash is like a unique ID, you can say, maybe. Yeah. Next is asymmetric cryptography. Asymmetric cryptography involves public and private key. Okay, so you give a plain text, okay, and you take a public key, you encrypt that, and you get the ciphertext. You take a private key and decrypt this, and you get the plain text. Okay, so public key is at the center end, private key at the receiver end. Okay, so it's like if you have a WhatsApp, right? So in WhatsApp you will have your private key and your friends will have your public key. So they will take whenever they are texting you like a hi message, so they're gonna take your public key and they're gonna encrypt that, and they're gonna send you using your private key. You're gonna decrypt it. Okay, that's like an example of how the public and private key works. Okay, so next here comes our header format. So what do we actually do? What is the difference between a signed firmware and unsigned firmware? It's just simple. Okay, signed firmware will be having this header. So you have this header, right? So you have this firmware, we're going to attach a header to it, which makes it a signed firmware. Okay, so let's jump into header. What exactly you have in header? So header is something like you have a starting of header something called as magic, and end of header you have something called as so these two are, we are given uh, few values to it. So this is hard coded values, so this magic and bootcamp anything. Next comes our image size. So what is the size of your image firmware will be given here. Next we have a type length value. This type length value is basically TLV for your next. It gives information about your next field. Okay, it will give what is the type, what is the length of the next field, what is the values in the next field. Okay, those things will be given here. And this image version will have the image of the image version of this firmware. So what version you are signing today and those things. Then we have padding. So padding is something where if you want to add in future more fields to the header, we have given the extra space in the thing, so that you can, if you tomorrow you want to add some more logic to the header, you can add it. Next, TLV is for your timestamp. So timestamp is when you're signing the firmware. Then we have your TLV for image type, which type of image you're signing. And then you have padding. Here also just left some padding so that you can have some in the future. Then we have TLV for digest. Here is interesting part is, so now we're gonna take the firmware and the header till here, and we're gonna get the digest of it. Okay, next is a TLV or a pubkey digest. So we're gonna take the public key and we're gonna get digest of it. Okay, and we'll store it here. Next comes your TLV for your signature. So once everything is done, you're gonna sign the you're gonna take this firmware and the header till here, and you're gonna get the signature. You're gonna take the public key and sign this, and you're gonna store it here. Okay, So on a device, you will be having your bootloader will be having the private key, and it takes the private key and it will verify the firmware. That's how it works. Okay. uh, yes, so let's go into my repository. Yeah, yeah, this is my repository here. So this is a you can find this repository under my name. This is the open source project written completely in Rust, sign in tool. Okay, so it's what if you go here, what does it say? This tool helps to sign the image using the private key and verify using the public key from the given certificate file. Okay, so there are some steps you can follow if you are using this signing tool. So sign the update firmware and sign the boot firmware using these commands are given here. And you also have the third step where you can put this which memory location you can burn this firmware. And the fourth is you can it will redirect you to the Rust boot, where you can boot, you can put the bootloader at the beginning of the flash. And then we have testing, how you can test, and we have a small video about it. If you go into the structure, folder structure, you have examples and you have source, and there are some of the files. We don't care about it, and we just focus on the cargo.toml. Cargo.toml has SHA-2, which hashing function we are using, and this 256 thing we are using elliptic cryptography, so we are using this file. And we also have random generator, we have slice, we have signature cret, and we have file time is used to timestamp. Okay, so here if you go into source, you're gonna find there are so many files here. These are the files which writes logic for signing and stuff like that. So importing a sign key, or maybe pre-hash sign, all these functions is a little more detailed things. Signature is where you gonna find okay, this is like a verification step. So once you are signed the firmware, the verification things are there in these things. And also you also find a public key. So basically we have one test public key and one test public key for testing this project. Next we have signer.rs. Signer is where you can basically this is a function which will be called from our main function to add the header. So like set image key and all these things. So these are the these are the inbuilt function which will be called from our main function. So if you go to examples, so example is where you're gonna have your sign the boot image and sign update image. So sign boot image will boot your sign firmware, boot firmware, and update firmware will sign boot update image will sign the update firmware. Okay, so let's go to VS Code to understand in more detail how what exactly is happening in boot for image. So let's go to the source here. So if you go inside source, you're gonna find all these things. You can just go this repository, it's open source. Examples, sign the boot image. So first step is you need to have the binary of your boot firmware which you wanna sign. So you can keep the binaries here, and respective signed binary will also come and reflect here. So once you sign it, okay, let's go in detail. So we have some of the array defined initial steps defined here. So first step is we're gonna find a timestamp when you're gonna sign the firmware. And there are a lot of we have different steps. So all these are headers. So if you have seen this header, right, so magic, TLV, image size, image version, all these are here. Okay, we have setting here. So first we're gonna set the image key size, which is your image key size, basically this is this one. And then we're gonna set our type length value, TLV. And then we're gonna set our image version, so which version of image you gonna put. And then we have padding will be added internally inside. If you go inside this function, you're gonna find the information required for padding. You can see the padding, right? So set image version, and padding will be added along with it. Okay, so next is timestamp. So you're gonna add timestamp. So we have a timestamps TLV, or basically this TLV means that type length value, how much bytes you're gonna be there, you're gonna adding. So we get timestamp from our function here. I think we're gonna take a timestamp from here, and we're gonna add it here. If you go inside this TSP, yeah, timestamp we are gonna extracting from this mtime. So and we're gonna putting inside this. So we have put a timestamp now. Next is your image type. So image type is something you're gonna take from here. If you go here, so you're gonna give some image type is like 2 and 1 is like hard coded value, and then we're gonna go next is our digest. So this step is completely finding a hash of the whole. So you there are two things here. One is the firmware, another is the header. So we're gonna take from here to here and these things. Okay, so we're gonna take all the things we added till here into a buffer and a firmware into a buffer, and we're gonna do the hash and we're gonna store it inside. Okay, so this is in the hash. So we got a digest here. Next step is to find the hash for your public key. So we take the public key from our basically now we are taking the public key from internally from the if you go here you're gonna find public key somewhere here. So we are just for temporary person we have just stored public key here. So we're gonna take this public key and we're gonna do the hash of it. Okay, so and in the real time you can also have the private key, and from that private key you're gonna do the get a public key. So just for example purpose we're just using this thing, and you're gonna store it inside your header. So now we got the public key, and we also found the digest of public key. Where is it? Yeah, you're gonna and now we're gonna store this thing. So these two field represent, so we are these two things, so SHA-256 digest and public key digest. So we have stored the digest of these thing, and next TLV and pub key digest. So once this is done, we'll sign the entire firmware and the header. Okay, so we have something called as ECC256TR. So we're gonna copy the private key, okay, into this thing, and we're gonna do the signing. So once signing is done, we're gonna store that signed image inside this field. Okay, so set signature value will help you to put the signature at this point. So once this is done, we're gonna put your we're gonna put our header. So we're gonna put our header last. It is called as end of header. So end of header will be added here. So now everything is done. So I think we're gonna create a file called as boot image signed image, and we're gonna store inside this thing. So basically this you can have your custom name. We're gonna take the name whatever you give, and we're gonna sign it, and we're gonna assign it. So once it's done, we're gonna do it. So these steps are also these verification stuff will be done in the bootloader end, but we are also doing it here itself, so that we can verify whatever we've done. This is just for verification, but if you go into Rust boot, right, you're gonna find something called as RB Signer. So RB Signer is a clear implementation of complete signing tool with more enhanced or proper way. Okay, like properly optimized code is there in that. So let's go to the repository. So if you go to repository here, you're gonna take some I'm just following the repository itself so that it'll be easy for you to sign it. So if you go and take this command, just copying this command. So basically this command is like cargo run example sign update image. So you're gonna update your update firmware. Okay, so go to your command prompt and just use this thing. Okay, so just run this command. So you gonna so now you got your so you had your bin file here, and you got your signed bin file. Okay, so what are information output if you see here? So you got a lot of information available here. So it is giving you something called as epoch time. So we're basically using the epoch time. So we're also printing the timestamp when we actually signing a firmware, and then we are also giving the length. Okay, and information, and we are giving a binary hash information. We also printed the public and private key present in our ECC256 directory, and then we're gonna get our signature type, signature fit image type. So all these are signatures whatever we have done. Okay, and then we are converting it to value. So this information is not required for you much. So this is just additional information given so that you can understand what's happening along with it. So we're just printing all this thing to understand purpose. So NIST256 is a ECC elliptic cryptography what you're using it. So finally this is important. Okay, this is the Rust boot header. Okay, this is the 256 byte header what we generated from all the information available here. So you can find the magic, you can find a TLV, length, and all these things inside here, and extra things will be FFF if there is no much data available, no much currently we have a very small header. this is a padding, you can say. This will be used for your future purpose. If you want to add few more fields into it, you can add here. Okay, so let's have a demo. So I think I have a video here, you can just watch. So this is a basically I have signed the firmware, boot firmware, so it will bring the green LED, and so once bootloader verifies that, so only then the green LED will be blinking. And then we have a update firmware where you have this red LED. Okay, so once update is there, so it swaps the thing. So now the Rustboot is also available at the beginning of starting address of your bootloader. Okay, so now you can see it is the verification is going on. So once verification is done, the green LED will start blinking. So once the green LED is done, so now update firmware is getting verified from the bootloader. So once it is verified, you can see that LED starts blinking. So even if you reset also, you can find now the update firmware will be keep on blinking it. No, that's the thing. So so now the whole thing has been swapped, and update firmware will be blinking. Okay, so this is about your signing tool. So you can find this repository in my GitHub page, and the steps involved to use this also given here. There are basically 5 steps you have to follow in order to make it work. Okay, then thank you. This is about the signing tool. Yes.